Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problem section, and in the search question, search 41. So 1 minute. So 41 and hit enter. So there is a problem number first missing positive. It's come under the hard category. So basically it's not as much hard. You can say it's either there are two approaches. One approach is very easy, and the one which is being asked, that is little bit medium but not hard. So let's click on it. Okay, so first missing positive. So given an unsorted integer array, so we have some array is given, find return the smallest missing positive integer. So we just need to run the smallest positive integer. So if we just consider this statement now, then it's very easy question. But like the main thing is the question has been asked, you must implement the algorithm in O of n and use constant extra space. So you should not use any extra space, and there should be only one loop, right? So how we are going to solve this question? And so what is being asked is we need to find the smallest missing positive integer. So what all are the first we should know what are the positive integer. So positive integers are 1, 2, 3, and so on, right? So starting from the 1. Okay, now we have, so let's take first example. So 1, 2, 0. So which number is missing? So 1 is there, 2 is there, right? So 3 is not there. So first smallest missing positive integer. So 3 is the first smallest positive integer which is missing. So answer is 3. Now let's take the next problem. 3, 4, minus 1, 1. Now 1 is there, 2 is not there. So 2 is the first smallest missing positive integer. Now take the next problem. 7, 8, 9, 11, 12. Right? So, but the number should be from 1 to 3. So is 1 is there? No, 1 is not there. So 1 is the answer. 1 is the smallest positive integer which is missing. Let's suppose the array is 1, 2, 3, 4. Now what is the answer? So 1 is there, 2 is there, 3 is there, 4 is there, then 5 is not there. So 5 is the first smallest positive integer. So that is not there. Right? So this is the question. So first approach is uh, what we can do is let's just ignore this thing, whether we should use extra space or whether we should not use extra space. Just ignore this second line for the time being. Right, first we will try to implement by any means, right? So we need to find, like, the number contains could be the negative, so we don't need to worry about the negative numbers, right? Okay, so given an unsorted integer array numbers, return the smallest missing positive integer. So we have given an list, so right, so a list is given. Now how we are going to find? If we just run a loop for I in, like, if there are 3 elements, then like the number should be at like 1, 2, 3. If there are 4 elements, then 1, 2, 3, 4. If something is else present, then let's suppose, because to understand the question is important. Let's suppose 1, 2, 4 are there. So what is the length of this array? 3, right? So if all elements are present, 1, 2, 3, then we can say the 4 is missing, right? But if 1 to 4 is given, so if the length is 3, we have to just check whether, if the length is 3, we have to check whether 1, 2, 3 exist or not. If these 3 doesn't exist, then we are going to return the particular number. If all the number are present, then we are going to return the n plus 1, whatever the length is, then we are going to return the n plus 1 as an example. So we have 1, 2, 3. So what is the length of our array? 3. then we will what numbers we have to check? 1, 2 and 3 only. So 1 is there, 2 is there, 3 is there. If every number is there, then what we are going to return? N plus 1. N plus 1, which is 4, because 4 is the first positive number. So in this case, n is equal to 3. So we need to just search 1, 2 and 3. So 1 is there, 2 is there, 3 is not there. So we will going to return 3, right? So the simplest approach is, so we can do is, so n is equal to length of nums, right? So it could be 3 and 4. Now we need to run a loop for I in range. So from where we need to search? We need to search from 1, and we need to search n as well, n plus 1, right? So what we have to do, if I in nums, if I means like 1 in the num or not. If I not in nums, if I not is num, then we are going to return I, right? Otherwise, we are going to return n plus 1, right? So which is perfectly okay. Like, let's try to run it. So our sample case has been we have not done anything. We have just, like, the thing is, because we just calculated the length, and we know n is equal to 3, 4, 5. So we are going to check first four element. If all are exist, then we are going to return the next element. All right. So as I told you, so if array is 1, 2 and 3, so n is equal to 3, then we are going, which number we have to check? 1, 2 and 3. So the same thing we are doing is, so we are starting from 1 until 3. So we will check, okay, 1 is there, 2 is there, 3 is there. Okay, if everything is there, then loop is finished. If everything is there, then loop is finished, because we can't run till infinity loop, because like positive number can be infinity, right? So if all these three number are exist, so the first positive number is n plus 1. All right, that is 3 plus 1, 4. Otherwise, if any number is not there, so let's suppose it's 4. If any number is not there, then it will going to print the 3. All right. So first solution is this. So if you try to submit it, it might fail. So let's try to run it. So we are not using any extra space in this, but it got failed. That is the time limit exceeded. Even though we are just running one loop and we are not using any extra space. So 4 test cases has been failed for the high, like where the input is very, very high. So if, so in the question, it is also mentioned we have to use the OFN. We are using OFN. In this question, it is mentioned we should not use the extra space. We are not using any extra space, but our test cases are not running fine. Like 171 test cases are running only, right? So let's try to use some extra space. First try to solve this problem, time limit exceed. So what we can do is, because we know we are searching in a list, and like how the search operation occur in the list. So let's go 1, 2, 3. So if I have to search 1, then it is going to search across all the element. Then if I have to search 2, it is going to again search across all the element. If I have to search 3, then again it's going to search all the elements. So every time of and this operation is performing. So what we can do is, we can make set from that list. So set of nums, and we are going to search in that particular set, because in the set, the search operation big O of 1. So let's try to submit it. So num set, okay, s is small. So our solution has been accepted, but you see, we are using like a very huge memory, right? Because we consume the extra space. But in the question, it is mentioned we need to run OFN. We are running in OFN. In the question, it is mentioned you should not use extra space, but we are using extra space because we created some extra set here. So we are using some extra space. Then how we can do without using extra space, but within big OFN? So this is one solution, which is also fine. Okay. Now let's try the another approach. Let's go to the like whiteboard. So what we will do is, let's suppose n is, we will take this example. So this example which will take. All right, 1 second. So we are going to take the example which is on the right hand side. So we have number 182 minus 3 3 2. So n is equal to 6. So what is the first positive missing number? So 1 is there, 2 is there, 3 is there, so 4 is not there. So answer is 4. But how we are going to check without using extra space, and we have to make sure all the test cases has been run. So what we can do is, because like what we can do is we can place all the number to its own position. As an example, so we have 1. So what we can do is 1 should be at the first position, 2 should be at the second position, 3 should be at the third position, 4 should be at the fourth position, 5th should be at the fifth position. Right, 6 should be at the sixth position. Then first we try to place all the number on its own position. Right, so only those number which are less than 6 or equal to 6 and greater than 0, because in this array only 6 number can be accumulated, 1 2 3 4 5 6. So we are going to run a loop from 1 to 6, right, only till this array. So as an example, so we have this array given, so we are running a loop. So first we are here 1. So where ideally 1 should be like present, so 1 should be present, should be at the first position. So 1 is at the first position only, basically at the 0th index, which is fine. Now its second number is 8, so 1 is like 1 is at the first position, which is perfectly fine. So now second is the 8, but 8 is greater than 6, so we are not going to check. So we are not going to check this. All right, so just ignore that. Leave at the same position where the 8 is. Now the third is 2, 3. So 2 is less than 6 and greater than 0. So where the 2 should be exist, 2 should be exist after 1. That is at the second position. That is at the index 1. So but it is at the index 2. So what we can do is we are going to replace 8 and 2. So we are going to replace 8 and 2. So now it's 1 2 8 minus 3 3 and 2. Now we are going to check minus 3. So it is less than 0, because we have to check only positive number. We will ignore the negative number. So we will ignore this. Okay, then we will proceed further. 3. So 3, where should 3 should be present at index 2. Index 2. But 3 is it here. So what we can do is we will swap 8 and 3. So 3 and 8 has been swapped. Now next is 2. So where the 2 should be present, 2 should be present at 2. So we because 2 is also here, 2 is also here, so we can swap the array will be same. So our output array is this 1 2 3 minus 3 and 8 and 2. Now we can just run a loop. We are going to run a loop and we will check whether all the elements are there or not. So 1 is there, 2 is there, 3 is there, 4 is not there. So at the fourth position, we are expecting 4. So 4 is not there. So it means 4 is the first missing number, which is like uh, absent. Okay. So the same thing like we have to do. So let's try to do in the code. Okay. So let's calculate the length. Length of nums I is equal to 0 while I less than n. Okay. So first, what we have to do when we get the first number. So first get the number if nums of I. Alright. So we found the first number. Now we are going to check whether we need to check this number or not. How we are going to determine like if the number is greater than 0 and less than n, then only we are going to check. So if number is greater than 0 and number less than equal to n, so n could be there, like 6 could be there, like 1 2 3 4 5 6, and the number, this number this number should not equal to, let's suppose this 2, we are expecting 2 should be at this position, 8 like this 1 second, we are expecting 2 should be at this position, but 2 is not this position, then we are going to swap. So what we have to check, if number not equal to the nums of. So number is 2. So where it should be there? It should be at present at 1. That is 2 minus 1. So number minus 1. So if it is not there, then what we are going to do is, so nums minus I, not I. Just a second, something is wrong. It, so what we are doing is, one second, I also got confused. So we are running a loop. So we found the first number 1. Second, we found the first number 1. Okay, so then we will check whether we need to check this number or not. So we will check, okay, this is greater than 0 and this is less than 6. We are checking is the greater than 0 and is the less than or equal to 6. Then only we are going to swap. And when we are going to swap, when the number is not equal to the when the number is not at its exact position, because for the one we don't have to swap because 1 is on its correct position. But how we are going to determine whether the number is on its correct position or not? So if number not equal to the number present at this index. So number present at which index? I index. Number present at I index or I minus 1 index. So I is 0. One second, just a second. We were correct only. So that is a num minus 1 because the number is 2. Number is 1. So we are expecting number should be present at the 0. So 1 minus 1, 0. Number is 2. So we are expecting it should be present at 1. So 2 minus 1, 1. So if the numbers are not equal, then we are going to swap. Then how we are going to swap? Nums of I, nums of num minus 1 equal to nums of num minus 1 comma nums of I. So we are going to just swap. Else I is equal to I plus 1. Now this is the also the important part. I will tell you, like generally what we will do is in while loop, in every condition we are going to increment I is equal to I plus 1. But here I am not going to increment like I in if condition, but I am going to increment in the else condition. The reason is, if you see this example, the second example, that's why I mentioned the second example. So we have number 3, 4, minus 1, 1. So n is equal to 4, right? So n is equal to 4. So we will pick the first number. First number is 3. First number is 3. Whether 3 is greater than 0? Yes. So as per code, whether 3 is greater than 0? Yes. Whether 3 is less than equal to 4? Yes. Whether 3 is at its own position. So where it should be, 3 is expecting at this position, 2 position. No. So the number at 2 is not equal to 3. So what we are going to do, we are going to put here, we are going to like basically swap 2 with this and this will this. So we are going to swap. So we swap the number. One second. So now we swap minus 1 with 3. So minus 1, 4, 3 and 1. So next number is 4. Next number is 4. So 4 is greater than 0, 4 is less than equal to 4. But is 4 at correct position? No. 4 is not at correct position. So we are going to place 4 at last and we are going to swap with 1. So 1 is here. Alright. Now we are going to check 3. We are going to check 4. But if we just only do this, minus 1, 1, 3, 4, because we already check 4, then we have to check 3, 3 is already there. Then we have to check 4, 4 is already there. So we have minus 1. So once we swap now, like in this case, we swapped 4 and 1. In this case, we have swapped 4 and 1. But we have to check whether the number which we swapped is at the correct position or not. Because we swapped 4 and 1. So 1 itself is not at a correct position. So we don't have to start from 3. We have to start from the same number again, 1. Right? So we have to start once we swap now, once we perform the swap operation, we are not going to check the next number. First we have to check the swapping number itself, because in this case 1 is not, 1 should be on the 0th index, but 1 is at the first index. So we are going to swap 1 with the -1. So that's why when we are swapping now, when we are swapping, at that time we are not incrementing I. So let I will be remain same, so that the same number going to be check again. Other events, once we are not swapping, then only we are going to increment I. So at the end we will get some list. At the end we will get some list, 1 -1 3 4 or 1 2 3 4. Then what we have to do, we have to just check the number. So for I in range of L, what we have to check, if nums of I not equal to, so number at I is not equal to I plus 1, then we are going to return I plus 1. Otherwise we are going to return N plus 1. So basically, let's suppose we add 1 -1 3 4. So we will check we will check till 4. So number at 0, that is, so because we are running from like a 0 to 4, so 0 1 2 3 only, 0 1 2 3. So number at 0 is 1. So whether 1 is equal to I plus 1, yes, which is fine. Now second, so number at second position is -1. Whether -1 is equal to 2, no. So 2 is missing. That's why we are returning true. If all the numbers are present, 1 2 3 4, it means the next number is missing, that is 5. So for that we are returning return N plus 1. So let's try to run it. So our sample case has been accepted. So let's try to submit it. Now you could see we improve some memory, right? So this is the like solution. So it's not like very difficult question. If we just know the trick now, the trick only is we will put the number at its own place. So once we put the number at its own place, then the rest thing is like very easy. Then we have to just run a single loop, and at the single loop we have to check like, okay, what number is missing? One is there, two is there, three is there, then four is not there. We are going to return four. One is there, two is not there, so we are going to return two. Right? So the thing, or if they have mentioned you can use the extra space, then it is very easy question, because if you can use the extra space, we can create a set, and in the set we can perform one operation from the set. We can just check, okay, whether one is there, okay, there, whether two is there, not there, then return two. If all the elements are there, then we are going to return N plus 1. So that's it. That's the end of the video. Thank you.